So we're going to prove and apply properties of parallelograms and use those properties to solve problems. So first, let's start off with what it is to be a parallelogram. So a parallelogram is a quadrilateral with two pairs of parallel sides. So I'm looking at a quadrilateral with two pairs of parallel sides. So this side parallel to this side, and this side parallel to this side. So let's look at some of the properties of a parallelogram. So we already know it's a quadrilateral with two pairs of parallel sides. Remember, we show parallel by two lines like this. Parallel sides, I'm sorry. So if I go down here, look at this little figure right here. It says opposite sides are parallel. To show opposite sides are parallel, we put the little arrow marks on opposite sides, showing they're parallel. One arrow with one arrow means those sides are parallel. Two arrows with two arrows means those sides are parallel. So let's look at the first property. Opposite sides are congruent. Opposite sides are congruent. Remember, this is a symbol for congruent, and congruent means equal. So down here, if I'm looking at this parallelogram that I've drawn, to show opposite sides are congruent, we say that this side is equal to this side, and this side would be equal to this side. So the next one is that opposite angles are congruent. So I'm talking about angles off of each other, not right beside, but opposite. So this angle would be congruent to this angle. And this angle would be congruent to this angle. The next one, consecutive angles are supplementary. Consecutive angles are supplementary. What does it mean to be supplementary? Remember, that means to add up to 180 degrees. So if I knew that this angle was 1 and this angle was 2, angle 1 plus angle 2 should equal 180 degrees. And the last property, the diagonals of the parallelogram bisect each other. So if I draw this diagonal and I draw this diagonal, the diagonal cuts the other one in half, so that means this part would be equal to this part, and then these parts would be equal to this part. So not all of them are equal to each other, but where they're bisected are equal. So let's look at the first example. It says in parallelogram JKLM, LM, so this side right here, is 86 millimeters. LK is 100 millimeters. And angle JML is 42 degrees. It says find the following values. So the first one I'm looking for is JM. And I know this is a parallelogram, so I know that opposite sides are congruent. So JM would be the same length as LK, which is 100 millimeters. And then I'm going to go ahead and skip down to number 3 because I just want to do my sides first. I'm looking for JK or KJ, and it's opposite of ML. So I know that JM or JK is going to be 86 millimeters. Alright, so let's try to find angle J, KJM, this angle right in here. So I know that angle J and angle M should add up to be 180 degrees because consecutive angles beside each other, are supplementary. So I know that 42 plus J should equal 180. So when I subtract 42 from both sides, I end up with J equaling 138 degrees. So this is 138 degrees. So I'm going to go ahead and put that in there. And I'm going to go ahead and fill in the rest of my parallelogram. If this is 138, opposite from it should be 138. And if K is opposite of M, that means K should also be 42. So when it says what is LKJ, LKJ is talking about this angle, so it'd be 42 degrees. And MLK, this angle right here, is 138 degrees. Alright, so let's look at the next one. It says in parallelogram ABCD, so this parallelogram over here, it says find each measure. So I know that diagonals bisect each other. So this is equal to this, and this part is equal to this part. So the first one says find the length of AE. So I'm looking for this length right here. So before I can find the length of AE, I have to find Y. So I know that this part is equal to this part, so I should set up an equation. Y plus 10 equals 6Y. And then solve for Y. So I know it's subtract Y from both sides to get 10 equals 5Y. And then divide by 5 to get Y equals 2. So up here, I can plug 2 back in for Y. So 2 plus 10 is 12. So this length would be 12. And then Y times 2 is 12. So this side would be 12, which makes sense because they're supposed to be equal, like we said over here. So the length of AE would be 12. Now I'm going to skip down to all of them that pertain to this line. It also asks about CE. So CE, that length is 12 as well. And it asks about AC, the entire line. Well, 12 plus 12 would give me 24. So next up we have BE, this length right here. Well, I know that BE is equal to ED because the diagonal is being bisected by this other one. So I can say that 4x minus 6 is equal to 3x. So I'm going to subtract my 3x from my 4x and add my 6 to the other side. So I have 1x equals 6. So that means in this equation where I have an x, I can put in 6. So 3 times 6 is 18. And then 4 times 6 minus 6 is also 18. So it asks for the length of BE. Well, BE would be 18 inches. Sorry, all these are inches. And then it asks for the length of BD, the whole thing. Well, 18 plus 18 would give me 36 inches. All right, let's do the last one. It says in parallelogram WXYZ, this one over here, it says find angle X and find angle W. So in this case, I have x's in these equations. So I need to solve for x before I can find out what these angles are equal to. Well, these angles are side by side, so I know they don't equal each other, but they are supplementary. So that means 4x plus 7x plus 15 should equal 180 degrees because these are supplementary angles, and supplementary angles add up to be 180. So if I combine my like terms, I have 11x plus 15 equals 180. Subtract 15 from both sides, and then divide by 11. And I get that x equals 15. So I go back and I plug this in into my equation. 4 times x, so 4 times 15. 4 times 15 should give me 60 degrees. And then I use it for the other equation. 7 times 15 plus 15 gives me 120 degrees. And 120 plus 60 equal 180. So now I have the right numbers. So x is 60 degrees and w is 120 degrees. All right, let's turn our papers over. In the next side, 6-3 notes, we're trying to prove that a quadrilateral actually is a parallelogram. So there's 3 things that we can do to prove it. The first thing is that opposite sides have to be parallel and congruent. So if I'm looking at a 4-sided figure and I can prove that the opposite sides are congruent and they're parallel, then that means the figure is actually a parallelogram. So go ahead and plot the points. And the next thing we're going to do is find the slopes of the sides. So let's look at the slope of AB. So going from A to B, I have to go up 1, 2, 3, 4, 5, and over 1. So the slope would be 5 over 1, which is 5. Then it asks for the slope of CD. So going from D up to C, I go up 1, 2, 3, 4, 5, and then over 1. So my slope would be 5 over 1. So these slopes are the same. So I know that AB and CD are parallel. So let's look at BC and DA. So BC, going from C to B, I go up 1, 2, 3, and then negative 1, 2, 3, 4. So this would be a negative 3/4. And going from AD, DA, I go from D to A up 1, 2, 3, and then negative 1, 2, 3, 4. So a slope of negative 3 over 4. So these slopes are the same, so I know that these two lines are parallel. So I'm going to put this side is parallel with this side, and this side is parallel with this side. Alright, so I do need to prove that one of these pairs of sides, opposite sides, are equal. So I have to find the distance of the sides. So I'm just going to focus on BC and AD, these two. If I can prove those two sides are congruent, then I know that I have a parallelogram because they're parallel and congruent. So if I look at BC, I'm going to look at the points B, which were negative 2, 7, and C, and the points were 2, 4. So I wrote the distance formula up here, and we're going to use this. I have an x1 and a y1, and an x2 and a y2, so I'm going to let B be x1, y1, and C be x2, y2. So I'm going to plug these points into the formula. So I'm going to have the square root of x2 minus x1, so 2 minus negative 2 squared. And I know minus a negative 2 is plus a positive, so I'm going to go ahead and change that. And it's plus y2 minus y1 squared. So I'm just going to simplify this real quick. I know that 2 plus 2 is 4, so it's going to be 4 squared. And I know that 4 minus 7 is negative 3, so it's going to be plus negative 3 squared. And I'm going to simplify that one more time. 4 squared is 16, and then negative 3 squared, negative 3 times negative 3 is positive 9. So 16 plus 9 is this 25, so I'm left with the square root of 25, which I know is 5. So going from B to C is going 5 units. Going from B to C is going 5 units. So let's find out from A to D. Well, I know that A was point negative 3, 2, and I know that D was at 1, negative 1. So I'm going to let A be x1, y1, and D be x2, y2. So let's plug this into the formula. So x2 minus x1, which I know minus a negative is the same thing as plus a positive. And change that. Squared plus negative 1 minus 2 squared. And I'm just going to simplify this. 1 plus 3 is 4, so that would be 4 squared. Plus negative 1 minus 2 is negative 3 squared. So I'm going to simplify like I did before, because I actually have the same thing. So 4 squared is 16, negative 3 squared is 9. And if you type negative 3 squared in your calculator, you have to put parentheses around it. If not, if you just type it like this in your calculator, the calculator squares the 3 and then multiplies it times a negative. And that's not what you're trying to do. You're trying to take negative 3 and then square it. So it would be negative 3 times negative 3. So I know that 16 plus 9 is 25, and the square root of 25 is 5. So I was able to prove that I have a pair of parallel sides, and that same pair of parallel sides were also congruent sides. congruent opposite sides, and parallel opposite sides. Opposite. So I can say that this figure is a parallelogram. So let's move on to the next one. The next one says, show that GHJK is a parallelogram if M equals 12 and N equals 9.5. So I'm going to prove that that this is a parallelogram because I'm going to show that both pairs of opposite angles are congruent. So you have to show that both pairs of opposite angles are congruent. So let's start off by looking at these opposite angles. I know that M is 15. M is 12. So 2 times 12, and I'm going to start with angle G. 2 times 12 plus 31 gives me this angle is 55 degrees. And then if I look at angle J, 7 times 12 and then minus 29 also gives me that this angle right here is 55 degrees. So this is 55 and this is 55. So I do right now have one pair of opposite angles congruent. So now I need to look at the second pair. So I'm looking at this one and this one over here. So if I look at angle K, I can say 12 times 9.5 plus 11, and 12 times 9.5 plus 11 is equal to 125 degrees. So now this is 125. So now I have to figure out what angle H is equal to. And I can't use that opposite angles are congruent because I don't know it's a parallelogram yet. That's what I'm trying to prove. But I do know that all the angles of a quadrilateral should add up to 360. So to find angle H, I'm going to say that 55, angle G, plus angle K, plus angle J, plus angle H should equal to 360. So 55 plus 125 gives me 235 plus H equals 360. And then 360 minus 235 gives me that angle H is equal to 125 degrees. So now I have another pair of opposite angles that are congruent. So since I have two pairs of opposite angles that are congruent, I can say that this is a parallelogram. So let's look at the last one. The last one says, show that RSTV is a parallelogram for x equals 6 and y equals 4.5. So in this one, to prove it's a parallelogram, I have to have both pairs of opposite sides congruent. So let's focus on RV and ST first. So I know y is equal to 4.5, so if I'm looking at RV, I know that 8 times 4.5 minus 8 is equal to 28. And then let's go to ST. ST is 6 times 4.5 plus 1, and that also equals 28. So I have right now a pair of opposite sides congruent. So all I need is one other pair. So let's look at RS and VT. So RS, 7 times x, which is 6, plus 6. So 7 times 6 plus 6 would give me 48. And then I need to look at VT. Well, VT would be 9 times 6 minus 6. And that would also give me 48. So now I have another pair of opposite sides congruent, because this was 48 and this was 48 and this was 28 and this was 28. So I know that I have a parallelogram because I've proven that both pairs of opposite sides are congruent.